Good morning. I am going to take the class for bellman algorithm. Bellman algorithm is an algorithm which is used to compute the shortest path from a single source vertex to all other sources in a weighted diagram. It is similar to Digister's algorithm, but we have to consider the negative edges also. So this is the working principles of bellman algorithm. So here, depending upon the vertices, we have to iterate the algorithm in order to get the shortest path. So for n vertices, we have to iterate for n minus 1 times in order to get the shortest path algorithm, in order to get the shortest path, shortest distance. So here we are going to see about the example for bellman algorithm. So see, here we have to see the put the negative edges. So for Digister's algorithm, we have to consider only the positive edges. Here we have considered the negative edges also. So there are 6 vertices: S, E, A, B, D, C. So for 6 vertices, we go for 5 iterations. That is n minus 1, 6 minus 1, 5 iterations. So this is the initial configuration. The starting vertex will be considered as a 0 and remaining thing will be considered as the infinity. So for initially we don't know about the distance, so that we have to put infinity for all other vertex. We can consider any node as a starting vertex. So here I am considering S as the starting vertex. For first iteration, consider the adjacent vertex of the S. So S is the starting vertex, so that the adjacent vertex of the S is C, S. So here the adjacent vertex is E and A. So we have to find the distance for E and A. The formula is same as the Digister's algorithm. Here T of E dot distance equal to T of minimum of T of E dot distance comma T of S dot distance plus cost between S comma E. So from the table, T represents table. From the table, the value of E is infinity. So we have to put the infinity, comma, from the table the value of S is 0. So we have to put 0 plus the cost between S and E is 8. So here we have to put the answer is 8. So minimum of 0 plus infinity, infinity comma 8. So which one is minimum? We know that 8 is the minimum as compared to infinity. So that we put infinity, 8 here. And similarly we have to find the distance for E. The same formula we have to apply here and get the answer is 10. Then immediately we are going to update the previous table as for A we put the value as 10 and E we put the value as 8. Then consider the another vertex A. The adjacent vertex of A is, see, the adjacent vertex of A is C with the cost 2. Then find the distance for C. Minimum of T of C dot distance. From the previous table we put infinity here, and T of A dot distances from the previous table the value is 10. So here we put the value as 10 plus the cost between A to C is 2. So find the minimum value between infinity and 12. So then the answer is 12. Then immediately update the previous value. Find the value of C is 12. And then another next vertex is B. The adjacent vertex of B is A from the original graph. B is A with the cost 1. Then find the distance for A. Minimum of T of A dot distance, the value is 10, comma, B dot distance, the value is infinity, plus the cost between B to A is 1. So here we put the answer is 1. So it is difficult to perform mathematical operations with infinity. So we just leave this step and go for next vertex C. So from the original graph, the adjacent vertex of C is B. Then again we have to follow the same procedure to find the distance for B. So the distance between B to C is minus 2. Then find the distance 12 plus minus 2. The answer is 10. Then immediately update the table. Then another vertex is D. Then from the original graph, the adjacent vertex of D is A to C. Then find the distance for A to C and then update the table. So here the value of D is infinity from the previous table. So it is difficult to perform mathematical operation by using infinity. So we have to leave this step and go for another vertex E, the last one. Then from the original graph, the vertex D is the adjacent vertex of E with the cost 1. Then find the distance with the cost 1. We have to find the distance for distance of D. Then we find the answer is 9. Then immediately update the table. So this is the result what we got from the first iteration. Then go for second iteration. So the input for second iteration is the result of the first iteration. Okay. Then the same procedure we have to follow. For starting vertex, start from the starting vertex and then find the adjacent vertex for S is A and A. Then find the same distance and similarly find the next vertex is A. The adjacent vertex of A is C from the original graph and then find the distance for C. The same procedure we have to follow here. Then find the distance for B and C, D, E. At last we got the result for second iteration. Compare the value of first iteration result and the second iteration result. For A we got 5. For first iteration A we got 10. So there is a changes as compared to first and second iteration. So we have to go for So we have to go for third iteration. So if the value was same, that is if second iteration, the value of second iteration and value of first iteration is same, then we stop the process. We need not to go for n-1 iteration. So here we have the different value because for first iteration we got the value of A is 10, but here the value of A is 5. So there is a changes. So that we have to go for third iteration. The same procedure we have to follow. Consider the starting vertex and then find the distance for E and A. Then consider A. Then find the distance for its adjacent vertex. Then B, C, D. Then finally we got the value is E. So then again consider the answer for third iteration. For S we got A0, A we got 5, B we got 5, C we got 7, D we got 9, E we got 8. So we have to compare this with second iteration result. So here is the second iteration result. So here we have the result for B is 10. But for third iteration, we got the result as 5 for B. So there is a slight change answer. So that we go for fourth iteration. The same thing, we have to consider A, B, C, D, E, and finally we got the result as this one. So 0, 5, 5, 7, 9, 8. Then compare with the third iteration result. Zero, 5, 5, 7, 9, 8. Third iteration result. Then fourth iteration also have 0, 5, 5, 7, 9, 8. Okay. So the third iteration result also, third and fourth iteration result are same. Actually, we have to go for n minus 1 iteration. As per the working principle, we have to go for n minus 1 iteration, but the third and fourth iteration result are same, so we need not to go for fifth iteration. Up to this, we stop this process. Here is the algorithm. So here the distance will be considered as the infinity and starting will be taken as the starting distance will be taken as 0 and then repeat the process here we have to insert the E represent edges. So for all elements we have to consider the each and every edges. We have to go for B minus 1 iteration time and then we perform the operation update. So update means for each and every iteration we have to update the distance value by using the resistance formula which it is given. Thank you.